Hello, my name is John Kariuki, and I will be demonstrating how to use the iostat.py script to monitor the bdev iostat for the bdevs in an SPDK application. Before we get started, I would like to acknowledge Jaichi Zhu, the developer who wrote the iostat.py script. The iostat command is a very powerful tool for monitoring the performance of block devices on a storage system. Users who adopt SPDK often ask questions like, why doesn't the iostat command show me my SPDK block devices performance? And how am I going to monitor the performance of the IO devices that my SPDK application is using? So let's talk about why the iostat command doesn't show the IO statistics for SPDK block devices. When you run the iostat command, the command queries the kernel block layer for the IO device metrics for the devices that are available on that system. And then the command formats those metrics and displays them in a format that's easy for you to read and understand. Well, in order for your SPDK application to use block devices that you have on your system, such as NVMe SSDs, those devices need to be unbound from the kernel driver. And when that happens, the kernel block subsystem no longer knows about those devices. So the next time you run the iostat command, it will not get any metrics for those devices that have been unbound from the kernel block subsystem. And what that means is you will not even see those devices in the output of the iostat command. For those of you who are relatively new to SPDK, I'm going to jump over to my dev box and show you exactly what I mean. So I have a dev box here that's running Fedora. And if I run the ls block command, you can see that I have a couple of NVMe SSDs. Well, actually, I have 15 NVMe SSDs on this system. And if I run the iostat command, you can see the output includes the IO statistics for the 15 NVMe SSDs that I have in the system. So the next thing I'm going to do on this system is run the SPDK setup script on the system. And what the script does is it unbinds the NVMe SSDs on the system from the kernel driver and binds them to a placeholder driver. And we're doing that in preparation for my SPDK application to consume those NVMe SSD devices. As you can see, once I have unbound those devices from the kernel driver, the ls block command doesn't show those devices as part of the kernel block layer. And that means that the iostat command doesn't show any metrics for those devices either. The SPDK community recognizes how powerful the iostat command is for system admins. And that's why in 2019, one of the members in our community, Jaichi Zhu, wrote the iostat Python script. The iostat.py script collects bdevio statistics from an SPDK application real time using RPCs, and then the script formats those IO statistics into a report that resembles the output of the standard iostat command. So when you look at the output of this script, it will look very familiar, and we will see that here in a couple of minutes. I'm going to go back into my dev box, and I'm going to run a script that will start an NVMe of a Fabrics target application, configure a few NVMe bdevs and a few LVOS, and then kick off some FIO jobs targeting the LVOS. So on my dev box, I have configured an NVMe of a Fabrics target with 8 NVMe bdevs, and I've put a couple of LVOS. I've put 2 LVOS on the first 3 NVMe bdevs. And when I run the iostat Python script, here is what the output looks like. When we look at the output, you can see the device metrics for each of the NVMe bdevs, right? Each of the 8 NVMe bdevs I have and the 6 LVOS that I have in this NVMF target. If we look at the metrics, they're very similar to what you see when you run the standard iostat on your system. The columns look pretty much the same, right? We have a column for TPS, the transactions per second. We have 3 columns that show the data read write transactions per second in kilobytes. So kilobytes reads per second, kilobyte writes per second, and discards per second. And then finally, the last 3 columns, they just show the amount of data read, right? So the reads in kilobytes, the writes in kilobytes, and the discards in kilobytes. If you are interested in just the bdev iostats for one bdev, you can use the -b parameter, right? So you can run the iostat Python script using the -b parameter and specify the bdev that you want to look at. So in this case, I ran the script and I specified that I only want the metrics for the NVMe 0 and 1, and that's what's being displayed. I'm going to recall the command and I'll run the same command against a bdev that I know is idle, and let's see what the output looks like. So as you can see, when I run the command, the output confirms that this bdev is idle. You can also poll the bdevio metrics periodically using the -i and the -t parameters. So in this example that I'm showing, I polled the bdevio metrics for that NVMe 0 and 1 bdev every 5 seconds for a total of 30 seconds. So the iostat Python script is going to run and it's going to show you the metrics every 5 seconds, and it's going to run for a total of 30 seconds. Finally, I'm going to poll the NVMF target application for the bdevio statistics for all the block devices I have in the target. And as you can see, I get pretty interesting data here, and the data is showing me that I have 4 LVOS that are pretty busy, and those 4 LVOS, they sit on 2 NVMe SSDs, NVMe 0 and 1 and NVMe 1 and 1. The rest of the NVMe SSDs and the LVOS are actually idle. They're not processing any IOs at the moment. Thank you so much for attending the SPDK, PMDK, and VTune virtual forum. Stay tuned for the next talk, which will be starting in a moment.